Hello guys, and welcome back to chemistry class. So we're having chemistry, and of course today we're going to look into Johannes Bronsted and Thomas Lowry theory of acid and base. That's Johannes Bronsted and Thomas Lowry. Right, theory of acid and base. So in the previous episode we have done an introduction into acid, base, and salts, and seen the definition by Svante Arrhenius, right? But in this particular episode, we are going to looking at Johannes Bronsted and Thomas Lowry acid and base. So Johannes Bronsted and Thomas Lowry define an acid as a proton donor. Proton donor. That is what? Proton donor. Proton, H positive donor, right? So they define an acid as a proton donor, while they define a base as a proton acceptor. So they say an acid will donate a proton, while a base will accept a proton, right? So this is the definition of Johannes Bronsted and Thomas Lowry. So they say an acid is a proton donor, while a base is a proton acceptor. Please note that this video tutorial, of course, is brought to you by the O3Schools JAMB CBT practice app. If you have been following our episode, you have heard a lot about this app, right? It is all you need to succeed in your exam. I will not say much more than that. So go to Play Store right now, download that app, activate it, practice. Join us in our UTME challenge every week so that you can compete to win prizes, and also of course, test how prepared you are for the exam. So we do that challenge, that UTME challenge is being completed by people who are writing JAMB for the particular year, right? So you win prizes, you see your score weekly, and then you know where your weak areas are, and you are able to improve upon them, right? So please, you don't need any other thing for your exam than that. Go to Play Store right now, download it, activate it. Activation will be 3,000 naira. So activate it, pay your money, activate 3,000 naira for your success in your exam. Right? You do not need anything to worry about once you have that app. All right, so let's go back to what we are talking about. So we said an acid, according to Johannes Bronsted, is a proton donor, while a base is a proton acceptor. So an acid will donate a proton, a base will accept gladly. To accept it or gladly. All right, so this is it. Now let's see examples of Johannes Bronsted acid. Example of Johannes Bronsted acid is what? HCl, hydrochloric acid, HBr, hydrogen bromide, right? We also have HNO3, right? We have H2SO4, right? We also have hydrogen cyanide. We even have water, H2O. These are what Johannes Bronsted, examples of Johannes Bronsted acids, right? HCl, HBr, HNO3, H2SO4, HCN, H2O, right? These are Johannes Bronsted acids. So I'm going to say acids, Bronsted acids. Now let's see base. Johannes Bronsted was base, right? So examples of Johannes Bronsted base is what? NH3, right? We have H2O, we have cyanide ion. These are Johannes Bronsted was bases, right? So the acid HCl, HBr, HNO3, H2SO4, HCN, and H2O, right? The base NH3, H2O, cyanide ion. All right, so these are examples of Johannes Bronsted acid and bases. But of course, if you are following me closely, you will see that there's water here, there's H2O here, and there's H2O here. As an acid here as a base also, the same chemical formula, nothing changes. All right, so why is water both an acid and a base? That's the question that any smart student will want to ask. Now, what is the simple solution or answer to this? The reason why water is an acid here and why H2O is also a base here is because this H2O here can donate a proton. It can donate a proton. It can act as what? As an acid, right? It can donate a proton to what? To form what? To give the hydroxyl ion, right? While it can also what? Accept a proton to give what? The hydrozonium ion, right? Let's see. See water, H2O, right? It can donate a proton right? I'm going to have H positive, then plus OH minus, right? So you can see here that water here is donating a proton to give what the hydroxyl ion, right? So in this case, water is acting what as an acid, H2O as an acid. All right. So H2O is acting as an acid here because it is donating what a proton, right, to give all this hydroxyl ion. Now it can also what accept a proton. So H positive plus what H2O, right? So now give us what the hydrozonium what ion. We have seen this before. So this is what H2O as a base. All right. So water is both an acid and a base because it can donate a proton to give us what the hydroxyl ion, or it can what accept a proton to give us the hydrozonium what ion, and that is why water is qualified here under the Bronsted and Bronsted-Lowry theory as an acid and as a what as a base. Of course, this is a very stable explanation towards that. Now, what else do we also need to know? We also need to know that when an acid, for example, let me take this off. When an acid, for example, Ha, donates proton, that it donates only one proton. Let's see, right? Ha, right? It donates what? A proton. So you can see the acid here. This is what is Ha, right? Now, once it donates, it has only one proton. So if it is donating a proton, what will be left? What will be left is what is the anionic part. What will be left is what? So if you see Ha, right, is donating a proton, I'm going to have what? H positive plus what? A minus. So since this proton has been donated, what will be left is this anionic what part. So this anion is a base itself. It's a base itself, and it is usually called the conjugate base of the acid. Right? So this anion is a base, and it's called the conjugate base of the acid. Why? Because this anion can also accept this proton back to now give us what? Ha. Can give us the acid back by accepting the proton back, right? To give us what? Ha. So usually we can what make this what we can change this to what to a reversible reaction that we can go in either direction. All right. So this is usually what represented. The equation usually represented what like this. The reaction rather is usually represented like this because it can go in both ways. The Ha, the acid can donate a proton. The proton, the anion that is left can accept the proton back to give us the acid, right? So that is that for that. Also, a base can accept what a proton can accept just one proton, right? So a base can accept one proton, and then an acid will be formed. Now, a base can accept a proton and to form what? An acid. The acid that is usually formed, right, from this kind of reaction is called what? It's called what? The conjugate acid. Right. So now, in this case, right, you can see the acid here is donating a proton, right, and then this anion that is formed, we say this is usually called the conjugate base of this acid. So that means if this is the acid, right, this one is what is the conjugate or the base, right? We say this anion that is left when this acid donates the proton is usually a base, and it's called the conjugate base of the acid. And together both of them they are called the conjugate acid base pairs. All right. So they are called what? The conjugate acid or base pair. This is the acid, this is the conjugate what? Base. All right. Now, the conjugate acid also because a base can accept a proton. Now, this is an acid what donating what? A proton. Now, what will now be left to what will be conjugate base. The conjugate base will be formed. Now, but when what? An acid, sorry, when a base rather is accepting a proton, what will be formed is what is the conjugate what? Acid. So, for example, now we're going to see, let's say, a base. Water is a base, right? We say it's a base, it's an acid. So a base is what is accepting what? Electron, a proton. So H plus plus H2O will give us what? H3O plus. For example, now, if you look at this now, you see that what? This is a base. Right, H2O is acting as a base there because it is accepting what? A proton here to give us what? An acid. So this acid that is formed is usually called what? The conjugate acid of the base. All right. So we're trying to explain the concept and phenomenon of the conjugate acid base pair. Right. Usually confused students, but it is very easy to understand. Right. You see here for this base part, sorry, for this acid To get the conjugate base, the acid needs to donate what? A proton. To get the conjugate acid, the base needs to accept what? Electron. All right. So now let's see some examples to drive conjugate acid base pair home. All right. Let's see some examples. Now the first example I want to see, of course, is H2O, which we have just seen just now. Water acting what? As an acid. So you see H2O, right? It can what? Donate a proton, H positive, then plus what? OH what? Minus. If you see this very well, you see that what? This water is acting as the acid, while this OH is what? Is the conjugate what? Base of what? Of this acid. Right? Because what? An acid, the acid here, H2O, is donating a proton. Now, let's see another example. Let's say HNO3, right? Donating a proton. I'm going to have H positive, then plus what? NO3 minus. Right? This is the acid, right? And then what? This is the conjugate base. So it will not be difficult at all for you to see a question on conjugate. This they say which of the following is the conjugate base of what? Of the following as of the acid. Then you now fill the question. No. So it's as simple as ABC. So you can see the acid donating a proton to form a conjugate base. The acid donating a proton to form a conjugate base. Let's see another example. H2SO4. Perhaps the one that will confuse you is this, right? Now, H2SO4 has what? Two protons. If you see this first one here, H2O having H plus plus OH minus, right? You'll be noticing that what? That the conjugate acid base pair differ by only one proton. The conjugate acid base pairs differ by just one proton. All right. So H2SO4, the conjugate base, of course, will now be what now? HSO4 minus then plus what? H positive. All right. Now, you can see that the conjugate base of what? Of H2SO4 is HSO4 and not SO4 2 minus. All right. So this is the acid, and then this is what? The conjugate base. So look at it very well. The conjugate base of what? Of H2SO4 is HSO4 minus and not SO4 2 minus, because the difference between a conjugate acid and the base is just one proton. All right. So let's see some other examples to drive this point home. Let's now see water acting as a base now. Right. Now this is water acting as an acid. And let's see H plus, then plus what? H2O. So this will give us what? Hydrozonium but ion, right? This is what? This is the base, water acting as a base, and then this is the conjugate what? Acid. Water, this is conjugate what? This is the base, this is the conjugate what? Acid. Because here water is accepting a proton, right? So also let's see NH3, H plus plus NH3 to give us the ammonium ion, NH4 plus, right? You see here, the ammonia here is what is accepting what? The proton to give us the ammonia. So this is NH3 acting as the base, while NH4 plus is what? Is the conjugate what? Acid. Right. So let's see the last one, HCl, H plus plus HCl to give us H2Cl plus. All right. Now here the base here is HCl, why this H2SCl is what? The conjugate of acid. So you may want to ask, why will HCl, which we know to be an acid, become it's now the base here, right? We're going to explain that later on before the end of this class. All right. So these are examples, right, of this different water reaction. You are seeing what? Water acting as water as an acid here, donating a proton to give us what? Hydrogen ion. You can see HNO3 donating the proton. What is left here is the conjugate base. So acid generally, you see, if you want to get the conjugate base of what? Of an acid, it just differ by what? By one proton. By one proton. The difference between the conjugate acid and its base is one proton. Right? It's just what? One proton. They differ by only one proton. So this is what these are examples. I'm sure that you understand everything about the conjugate acid base pairs. Conjugate acid base pairs. Right. So perhaps this is the one that usually confuses students. This H2SO4. Why is it not SO4 2 minus? It's not SO4 2 minus because the difference between an acid and its conjugate base is just one proton. All right, now that we have seen this, another important thing to note in this regard, of course, is the fact that I've stressed over and over again that the difference between an acid and its conjugate base is what? Is one proton. They differ only by one proton. I've stressed it. So make sure you put that at the back of your score. Put that, in fact, that is the most important part in this discussion. The difference between an acid and its conjugate base is what? Is one proton, right? So, for example, as you are seeing H2SO4 here, right? H2SO4 here, the acid, we say the conjugate base is HSO4 and not SO4 2 minus. Right? Because this SO4 2 minus is the conjugate base of HSO4. All right? Is the conjugate base of what? Of HSO4. So you can see if you want to do this now, you say what is the conjugate base? HSO4 is an acid, right? So the conjugate base will be what? Will now give us H positive plus what? SO4 2 minus. All right. So this SO4 2 minus is the conjugate what base of HSO4 and not the conjugate base of what? H2 what? SO4. You get? So that one what clears what the eye, right? It clears the eye because it now shows that what the difference between an acid and its conjugate base is one proton. All right. And then an acid is what? It's just more than its conjugate base. An acid is more than its conjugate base by one proton. An acid is more than its conjugate base by one proton. While a base is lesser than its conjugate acid. Look at it. A base is lesser than its conjugate acid by what? One proton. All right. So just note that and know peace. So to drive that point home, you could just say that what acid conjugate equals to conjugate base plus proton plus what? One proton. All right. Right. You can now say base plus proton give us what? Conjugate acid. Very simple. Right. So conjugate acid. So an acid is what? Conjugate base plus one proton. Right. While base plus proton give us what? The conjugate acid. Calm, right? All right. Now let's go ahead. So another thing to know, of course, is that what? Acids have basic character. Acids have what? Basic character. We're going to use this reaction H plus HCl to give us H2Cl plus to explain this, where this is what is a base and this is an what? It's an acid. All right. So we have said it that acid have what? Basic character. What we mean by acid have a basic character is that what? An acid has the potential to act as a base. An acid has the potential to act as what? As a base. All right. Also, a base has the potential to act as an acid and vice versa. Why? Because you can see that acid solutions or acidic solutions usually have what? A value called pH. All right. They have a value called pH to show their concentration. All right. Also, basic solutions have what we call what? pOH. All right, to also show that their concentration. All right, so that is why we're saying that an acid has a basic character. That means an acid can act as a base, and no wonder acid solution have pH values, while base solution have pOH values. All right, so now if an acid meets what? A stronger acid, right? In a reaction, an acid where there's an acid, then there's another stronger acid. Then what happens usually is that let's say an acid X now, for example, meets what? A stronger acid Y in a reaction, right? What happens is that this acid X that is less stronger than the Y will now act as the base. Why this Y now be what? The acid in the reaction. All right. So in any reaction where what? An acid X meets a stronger acid, a much stronger acid than it, Y, right? the X will act as a base, while what the Y will not act as the acid. So also when what a base B, for example, meets a stronger base C. So if the C is stronger, that means this base will not act as what? As the acid, and what? And the C will not act as the base, and vice versa. So it happens like that. That's why I'm saying acids have what? Basic character. So bases also have what? Acidic character. Sometimes a base can act as an acid, while an acid can act what? As a base, or has the potential to act like a base. So for example, as you are seeing here, HCl, we know say normal HCl na strong acid. We know HCl is a very strong acid. It's a strong acid, but here it's acting as a base. It is accepting what? A proton to give what? H2Cl what? Plus, to give what? This what? Acid. To give what? This conjugate what? This conjugate acid here. All right. So of course, this explains the fact that an acid can act what? As a base. It has the potential to what? To behave like a base. All right. So this is where we're going to end for today. In the next video, next episode, we're going to be looking at the definition by Gilbert N. Lewis. Please stay in touch. Enjoy, share, like, and of course comment on this video. Thanks for watching.